All right, friends and neighbors, welcome back to another networking video. It's time to start talking about DNS. Now, this is a big topic, so we're going to spend several videos working on this one. And I thought I would start with the problem that sort of caused the whole DNS system to be created in the first place. So we'll do this in two parts. We'll talk about first the problem, and then we'll talk about the solution. But before we do all of that, maybe we ought to define DNS. I mean, what is it? Why do we have it? Well, DNS stands for Domain Name System, sometimes Domain Name Server. Okay, so here's the thing. We use human readable names to access most things on the internet. So if you're going to a website, right, you type in some name that you understand. Even when you're accessing shares or something like that, you type in what you know about the human name for that resource. But of course, computers don't like human readable names. They don't use them at all. They need IP addresses. And eventually, of course, they convert IP addresses into binary numbers. So like many things in the networking world, we have a series of tables or a series of actions that are a mapping between things. So an ARP table is a mapping between IP addresses and MAC addresses. So the domain name system provides this mapping between human readable names and IP addresses. And so what a client can do is say, hey, what's the IP address that goes along with this human readable name? And then a domain name service server comes back with the answer. Oh, here's the IP address that belongs to. So it's names to IP addresses, but the reverse is also provided. So you can also do a lookup on an IP address. What's the name that goes with this IP address? And this is great when you're trying to look at network traffic and you're saying, where did that IP address come from? Why am I talking to that one? So you can do lookups that way too. So a fun thing to realize is that every time you go to a website, you usually don't go to the website first. The first thing you do is query DNS. And then, after you get an answer, you go to the website. But enough of all that. Let's begin at the beginning. So here's a basic question. How do I locate resources on a network? And then once I know where they are, how do I get to them? Okay. So let's see if we understand the problem, right? I've got all of these human named objects out on the network, and I might want to get to them. It might be a printer, it might be a web server, it might be a file share of some kind. It doesn't really matter, but I've got all of these things that I access by name. But of course, computers don't use those names. Okay, so here's what we could do, right? Here's an early solution to this problem. What if we took all of those names that are out on the network, right? All of those things that we understand, and then we put them in a file. And then alongside each one of those, we put the IP address that came along with them. Sounds pretty good. Sounds pretty good. Now, the reason that we use human readable names, obviously, is because, well, I don't want to try to remember a whole bunch of IP addresses. And it turns out that those are much more difficult to remember anyway. So after you create this file, some questions come up, right? So you've got this solution. Okay, cool. We'll put everything in a file. Great. Do we do that on every host? Should we do that on a server that's local on your network? Okay, maybe we'll do that because I don't want to run around to all the machines and keep this file updated. Okay, so we'll do it on one particular server, and then maybe what we'll do is we'll make that public. So we'll have this file, something called hosts.txt, and then what we'll do is we'll allow all of the nodes on the network to go out and query the server periodically and say, hey, can I have the updated version of the host file? Sounds pretty good. So we can do that via FTP or even TFTP if we wanted to. And so that's what we'll do. And so periodically we need to keep this up to date. All right, sounds pretty good so far. Now this particular problem of being able to keep track of all of these mappings, whether it's IP address to MAC address or MAC address to port address, is very, very common. So it's not like DNS was the first one to ever come across the problem, right? In the early days, when we were trying to build Ethernet frames, right, you had to go out and find the MAC address that went with this IP address that you were trying to talk to. Well, you had a couple of ways to do that. One of them was to put a file out on a server and then go get it. Well, it turns out that that's tough to keep up with. It's tough to manage because IP addresses and MAC addresses can change so often, and we're always adding and subtracting nodes from the network. Okay, in the end, it was decided that the best approach in that case was to do something distributed, right? So all hosts have the ability to participate in the address resolution protocol. So all hosts are. Now, another example is DHCP, right? We just got done talking about DHCP. So one way to do this would be to have some kind of file locally resident on the host. But of course, the minute things change, you got to update all of those files. All right. So let's develop a couple of protocols, RARP, BootP, that sort of solve these basic problems. There are even ICMP messages to help us with the problems associated with IP addresses and gateways and masks. But in the end, it was decided that a centralized solution where we have a DHCP server that can be queried by all hosts, instead of updating one file all the time, we have this sort of centralized resource, right? And then you can send out this broadcast message or do DHCP relay and find out your IP address. Okay, so this particular problem of having a whole bunch of nodes that need access to a bunch of information, either on startup or when they have a question, is not a new one. All right, so now there are other forms of discovery, other protocols that need discovery, like when you're looking for Windows resources and things like that. So the big question comes down to, should we do a distributed approach or should we do something that is centralized? Is there a server involved? Is there a protocol that we might invent that allows everybody to participate in whatever you're trying to accomplish? Okay. So how did name resolution work initially? Well, if you go back far enough, right, the internet looked a lot different than it does today. We had network access points, right? There were supercomputing centers and things like that, but there was a limited number of folks that were connected to what we might call the internet. Okay, so this was, right, NSFNet and all of that, sponsored by the Advanced Research Projects Agency. But it got popular, right? So it starts to grow. So we'll put that off to the side for a sec. We got to realize that the internet was this thing that had, sort of a finite number of users and networks. Initially, we had the Network Information Center, and they had a centrally administered text file, the hosts file, and it contained all of these mappings of IP addresses to host names. Now, this is before host names as we know them today. And what would happen is that there would be this conversation between all the folks that were running networks and the Network Information Center. You would get the updated host file pushed down to you on a regular basis, right? On a weekly basis or a couple of times a week. And then you would sprinkle it around to your nodes or to your local servers. And here's what that implementation sort of looked like, right? In Windows, there was an actual host file. And I've just got a couple of examples on the slide, right, where we've got what looks to be IP addresses and mappings to host names. Okay, very good. There's a line for the local hosts entry. Now at the time, Windows was also working a lot with NetBIOS, and so there was a NetBIOS mapping too that was a Windows-specific implementation. It was very similar to the host file. So again, the same basic problem. Let's look up resources with human readable names, but we need the IP addresses that go along with them. On Linux, /etc/hosts. Hey, it looks the same thing, right? IP addresses and then host names. And because we're going to work with CentOS build in a bit, we're also going to be aware of a couple of other files that are out there on Linux, especially resolve.conf. Here's where the wheels start to come off a little bit. The 1980s. Ah, yes, the 1980s. The quote that I have from RFC 1034 is the impetus for the development of the domain system was growth in the internet. So now think about this for a sec, right? You are the one that's going to manage this file. And all of these folks are joining. And it's not just one person a day, so you add the entry. It's hundreds, thousands, right? Exponential growth potentially in the size of the internet and the folks that want to participate. At the same time, right, we had the personal computer comes out, so more PCs coming out, right? Internet expansion, Windows distribution, web browsers depending on, what you want to read, Netscape, and all of those things back there in the early 1990s, right? The internet changing structure, providing a higher level of access. Okay, so now you've got this sort of feel for all of the amazing things that were happening at the time. So, how do we manage this host file? Well, you could have a file on every host. Yeah, that's kind of tough. You would have to update those host files all the time. All right, so let's put it on a server. Okay, great. Does everybody do it locally? Well, no, right? So we've got this centralized thing. But now, how do you make sure that you have the latest and greatest version of that centralized thing? The basic problem is the volume just became unmanageable. On top of that, everybody did host names just a little bit different, right? There was no clear format or structure to a host name. So one of those early RFCs, RFC 882, provides the discussion for the need for domain names. As applications grow to span multiple hosts, then networks, and finally internets, these applications must also span multiple administrative boundaries and related methods of operation. Okay, so what does that mean? Well, we got lots and lots of nodes, lots and lots of networks, and then internets. Now, this is not the internet, it is internet. So an internet is just a collection of networks. And then you've got to be able to get these queries or these updates across multiple boundaries, right? So you got to be able to get to an end host by name across multiple administrative boundaries. And if everybody's not doing things the same way, that creates a problem, right? So the number of resources, the number of locations of resources, and the diversity of such an environment, meaning that everybody does it differently, right, causes formidable problems when you want to be consistent about stuff. So it comes down to, is everybody doing things the same way? And the answer is no. Now, it gets worse. So, as it says here, again, from the discussion there in early RFCs, the problem for computer mail is more severe, while mail system implementers long ago recognized the impossibility of centralizing mailbox names. All right, so if you think about it, right, your mailboxes are named for you. How in the world would you centralize all of that over all the different organizations and everything else? We have a couple of different protocols. We have a couple of different naming conventions. So there's an increasingly large and irregular set of methods for identifying the location of a mailbox. And then you've got to get to the mailbox, or get to at least the mail server. So lots and lots of troubles associated with a subset of all of these, sort of end hosts or end user names inside the larger problem of how do we manage all of this namespace. And there are some examples of the problem down there at the bottom. Initially, if you just use, an IP address and a name, how do you do that? Well, maybe we got to find some way to realize what FTP actually means. Oh, it's FTP host. Okay, so but then you got to convert FTP host to something, right? So this is an increasingly complex and really, really challenging problem. Well, hopefully we've got our hands wrapped around the problem, right? Massive file sizes. Everybody's doing things different ways. How do you avoid the confusion of getting to all these names that might have been the same, that might have been repeated, using different formats? Oy, what a mess. Okay, let's tune in to part 2 for the solution, right? How was all of this managed? Tune in, that's kind of funny, right? Nobody really tunes in anymore. Except I did for the Bills game yesterday. All right, enough of all that. Thanks for watching. Like and subscribe if I helped, and may your packets always reach their destinations.